All right, let's talk about chemical reactions. But I want you to forget the boring textbooks for a minute. Today, we're going to reimagine the whole thing as one big, awesome party. You ready to see chemistry in a completely new way? Let's jump in.
So what's actually happening at this atomic party? Well, we're going to see how different atoms mingle, what kinds of games they play, and who the real influencers of the party are. It's all about changing the way we look at the world, at its tiniest level. So let's just start with this one idea. What if all those complicated formulas and equations were really just describing a party? A place where elements can mix it up, swap partners, and create something totally new. Just keep that idea in your head because it's the key to making all of this make sense.
See, at its heart, a chemical reaction isn't about destroying things. It's really just about rearranging them. The atoms don't just vanish. Nope, they just find new partners and build new things. It's exactly like taking apart a Lego car and using those exact same bricks to build a spaceship. The pieces are the same, but what you end up with is completely different.
Okay, so every good party has different activities, right? You've got the dance floor, the snack table. Well, in our atom party, there are three main events. Think of them like different party games that our atoms get to play.
First up, we've got thermal decomposition. I know, sounds a little intimidating, but don't let the name fool you. Thermal just means heat, and decomposition, well, that just means to break down. So all it is a reaction where you add a little heat and one thing breaks apart into a bunch of simpler things.
And the absolute perfect example of this? Popcorn. You start with a few hard little kernels, right? That's your one single compound. You add heat and pop. You've got a whole bowl of fluffy popcorn. One thing just broke down into many. That's thermal decomposition right there.
And if we were to write this out in, chemistry speak, it looks just like this. A single compound, we'll call it AB, gets hit with some energy, and it just breaks apart into A and B. Super simple, super clean, just like our popcorn.
All right, our next party game is called Simple Substitution. And, I kind of like to call this one the jealous reaction. This is where one bold single element comes in, sees a compound, and decides it wants to cut in, kicking one of the other elements right out.
The easiest way to remember how this works, just think of it like this. One comes in, one goes out. It's that classic move on the dance floor where someone taps another on the shoulder and says, "My turn." It's just a simple switcheroo. And when you look at the formula, you can literally see it happen. You've got element A all by itself, and it sees the compound BC hanging out. Well, if A is more reactive, it just boots B out of the way, forms a new compound AC, and leaves poor B all on its own.
And our final reaction type is double substitution. Now this one is way more civilized, way more polite. There's no jealousy here. Instead, you've got two compounds that meet up and just politely trade partners. They end up forming two brand new compounds. Everybody leaves with somebody new.
The best analogy for this is a partner swap at a square dance or something. You've got two couples on the dance floor, the music changes, and they just switch partners. Nobody's left out, and everyone gets a new partner to dance with. It's a really elegant and balanced exchange.
And in the formula, it's just as organized. You've got compound AB meeting compound CD. Well, A decides it wants to dance with D, which means C then pairs up with B. And what do you get? Two totally new compounds, AD and CB. A perfect swap.
Okay, so we've got the main party games down, but there's this really influential duo at this party. I mean, you literally can't separate them. They are behind everything from rust on a car to how your phone battery works. It's time to meet the chemistry twins, oxidation and reduction. These two are always together. So these two are perfect opposites. If one atom is losing electrons, that's what we call oxidation. Then another atom has to be right there to gain them. And that's reduction. You just can't have a loss without a gain. It's a basic rule of the party.
Now, to remember this, we have an amazing little trick. The first part is OIL. It stands for oxidation is loss. And what's it losing? Electrons. Say it with me, OIL. Oxidation is loss.
And the other twin? Well, that's Rig. Reduction is gain. A gain of what? A gain of electrons. So you've got oil and Rig. One loses, the other gains. Seriously? That one little trick will help you keep them straight forever.
But wait a minute. What actually causes this whole electron exchange? Well, at our party, there are two key players that make it all happen. You've got the giver and you've got the taker. These are the agents of change.
Okay, now this part can feel a little tricky, so let's break it down real slow. The oxidizing agent is our taker.
It causes oxidation by going around and taking electrons from something else. But by taking those electrons, it gains them, right? Which means the taker gets reduced itself. Kind of weird. On the flip side, the reducing agent is the giver. It causes reduction by giving its electrons away. And by giving away or losing electrons, it gets oxidized. It's a complete role reversal. The one causing the thing has the opposite happen to it.
Whew. Okay, we've been to the atomic party. We've met all the characters. We've learned the rules. So let's just pull it all together with a quick recap to make sure all of these ideas really stick.
All right, let's do this super fast. Ready? Chemical reactions are just atoms rearranging themselves. Thermal decomposition, that's when heat breaks things down. Simple substitution is when one element kicks another one out. Double substitution is that polite partner swap. Remember oil rig? Oxidation is loss of electrons, reduction is gain. And finally, the oxidizing agent is the taker, and the reducing agent is the giver. Boom, you got it.
So you see, the main takeaway here is that chemistry isn't just a list of facts you have to memorize for a test. It's a story. It's the story of how everything around us is built and broken down and then rebuilt again. It's a non-stop party happening on a scale that's too small for us to even see. And by understanding these simple stories, you've unlocked a huge secret of the universe. So the only real question left is, what story will you go out and discover next?